All right, you guys ready? Let's go. Class?
Yes.
All right, so thank you for at least pretending that you're excited to be here, because I appreciate that. I do. I appreciate everyone making sure their phones are off and away, your headphones are off and away, so I don't have to go and yell at anyone because they're playing with their phone, because their phone keeps going off every 5.5 seconds. Yes, you. Off and away. My dude, please make sure those earbuds go away. Please. I know you can hear me because you don't have the noise canceling. Come on. Please make sure those go off and away. Thank you. Thank you. Anyway, all right. Constructing a group frequency distribution. We already did frequency distribution the other day. Okay, yesterday in class, and now we're going to do another one with a bigger group. So this one has 40 students in this group. Group the frequency in the classes that are meaningful for the data. So if I'm just looking at all this raw data right here together, it's a hodgepodge. It doesn't mean anything, does it? Okay, so we're going to put it together according to their 10-point ranges. So I go 40 through 49, 50 through 59, 60 through 69, 70, 79, 80 through 89, 90 through 99. Now, frequency, we're going to see how many times this happens. How many times do I get a score in a certain category? And I'm going to either mark them off or tick mark them, or in my case here, I'm going to highlight as I go. I'm going to highlight. So I'm going to start in the 40 to 49 range by highlighting here. So let's see how many I have in this range. So I go 1, 2, 3. Only 3? Okay. Let's see. I got 3 in that range. And that's how we do this. That's pretty easy, right? Let's keep going. So the next one is the 50 to 59 range. So that was orange. Let's go that one. So now I have 1, 2, 3, 4, 5, 6. You guys agree? Okay, good. Next one is going to be 60 to 69. So 1, 2, 3, 4, 5, 6. Only 6? Yeah, 6. Next one is going to be in the 70 range. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Did you guys come up with 11? Yeah? Okay. Next one is 80 to 89. One, 2, 3, 4, 5, 6, 7, 8, 9? 9? Okay. And the last one is 90 to 99. 1, 2, 3, 4, 5. Should have 5 in that range. Let's go. Now that we have the data organized, what can you tell me about the data? Okay, so 70 to 79, this is the most, right? The most frequent. That's the most frequent. That happens the most. Okay, least frequent would be? Okay, so there's least. That's actually pretty good. And what does that tell me everything in this category here? From 70 to 99. That's A, B, and C, right? What does that tell me about the ABCs? Are these people in the ABC range more than the D and F range? Yeah. So that's actually pretty good test scores. Okay, not bad. Not looking too bad there. Everyone okay? All right. So we're going to use the same data coming up here on another one here in a moment. So histograms and frequency polygons. Histogram is a bar graph with bars that touch, can be used to visually display the data. This is the example that we did yesterday. We were talking about boys' ages maximum yearly growth. That's when guys usually hit the growth spurt and where they grow the most over a period of 1 year. So on this curve right here, if you look, right here in the middle is at 14, that's the most, and you can see how it tends to happen there. All right, so, and frequency polygon, you take the same thing and just connect straight lines in between the middle of each one. Stem and leaf plots. We're going to do a stem and leaf plot, and I'm going to need you to make one because the one I added to your notes didn't fit very well. So it shrunk the category, so it's not going to fit. So we're going to do it off to the side on the right hand once we get to that. So stem consists of the tens digits, leaf consists of the units digit. So we're going to take all this, we're going to do a stem and leaf plot for all this here. So it's going to start off with the stem, and we're going to work the same data that we had, but we're going to work it backwards. So I'm going to start with 90s this time, just because I can, because I feel like it. So this is going to be 90, 80, 70, 60, 50, and 40, but we're going to do this on another page. On my page, but yours, you have blank lines next to yours. So we have, starts with a 9, 8, 7, 6, 5, and 4. Now, this is how we figure these out. We're going to start with the 90s, and this is how we do a stem and leaf. Stem starts with the branch that they come up with. So that's the tens place. The leaves are every unit that I have there. So going back, and I'm going to go with my highlighter. So I'm starting with the 90s. So I had 93, 94, 92, 94, and 94. Was that all of the 90s? We only had 4 in the 90s? Did we have 5?
That's
We had.
fine.
Yes. That's wrong?
That's fine.
That's 5? Oh, I miscounted. Sorry. I miscounted. So now we're going to put these in order. So it's going to go least to greatest. So I have 92, 93, 94, 94, 94. So it's going to look like this. 92, 93, 94, 94, and what was the last one? I got 3 94s. 3 4s, like that. So it's kind of making a histogram that's going sideways here, isn't it? So as we fill this in, that's what we're going to do. And we put them in order. So each one represents a whole number. So this 2 is 92. This 3 is 93. This 4 is 94. And it occurred 3 times, didn't it? That's what a stem and leaf does. So let's look at the next one. So I'm going backwards. So we're in the 80s now. 2, 4, 88, 80, 81, 80, 87.
84.
I'm missing 84. Oh, down there. Okay. Is that all of them? Yeah? So on ours, I'm going to kind of do it here on the bottom so we can see. Let's put them in order. So the first number is 0, so it's 80, right? So I have 80, so it's a 0. What comes after that? Another 0. What comes after that? 1. There's an 81. Next one is? There's an 82. Another 2, right? Another 2. 4. Another 4. 7. And an 8, right? Yes. So I listed all these. Now we're going to put these over on the next one. So we're going to put these on the next one now. So 0, 0, 1, 2, 2, 4, 4. So 0, 0, 1, 2, 4, 4. Do what? There's 2 twos?
Yeah, there's 2.
Oh, sorry. Thank you for getting that. Next one is?
4, 4, 7.
And 8?
Yeah.
So if you notice the spacing on this, I'm trying to make them all uniform spacing, right? So by doing that, am I making a bar graph that reaches out this way? Yeah, that's what I'm trying to do with this. So I could also make a bar graph as I'm looking at this. All right, so the next one is going to be the 70s. And that's right here. So 70s, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah. Yep. All right, now you people right now, I already highlighted those in blue. I want you people to start by listing out the numbers like I did there. So I'm going to erase the previous one that we had. So I want you people right now doing the numbers real quick, and then we will add these in. Why do you guys creep? Look, you guys creep so much. You're like a whole foot further than the red line. I know, but look where the red line is. Move your backpack. That's where the front of the desk is supposed to be. That's crazy, right? Everyone creeps on me. All right. It's all right. We'll fix it. We'll fix it at the end. All right, you guys ready? There's 11 of them, right? Should be 11. All right, so let's go through. What is my smallest in the 70? So I got 1, a 3, a 4, 5, and you said another 5? 1, 2, 3. A 7. An 8. And a 9. Is that 11 of them? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yep. So let's transfer it over here. So what were the numbers again?
1, 3, 4, 5, 5, 6, 6, 7, 8, 9.
There we go. All right, I want you people right now to do, these are the smaller ones. I want you guys to do the 60s, 50s, and 40s right now by yourselves. Do the 60s, 50s, and 40s right now by yourself. Yeah, that guy's going next. Eco Brown?
Oh.
Because you're asleep and it's rolling on your paper. You are finishing these right here. No, look at what we have on ours. That's how long we close. Okay, it was long enough that you missed all of this. Put this down. Tell me to sleep. She's rolling on your paper. That's not tired for it. Use it to a spot. Listen, when I am that tired, I do fall asleep all night. Yeah, seriously. I do too. Alright, let's see what we have here. So my 60s. I believe there were 6 of them, right? So what did we get? 3, 6, 6.
7, 8.
Very good. And boxing that off. Next one, what about the 50s?
0, 4, 4, 6, 7, 9.
9?
Yeah.
Okay. And the 40s? There we go. So now we have a sideways box, right? We clearly see we made a box out of this using stem and leaves. Does that make sense? Okay, good. Now the next thing that we're going to do is talk about deceptive in visual display and design. Now, when you're looking at watching TV and let's say the news or political ads and all that other stuff, a lot of this stuff actually happens every day. Every day. So I want you to look at these two things before you start yelling stuff out. This is the same data. It's the same data. I want you to think about what's different and how is this somewhat deceptive. It's the same data. All right, anyone? Yeah, go ahead.
It's more something on the left.
It's more what?
Zoomed in.
More zoomed in, or it's stretched out, right?
Yeah.
Yeah, it's stretched out. So even though that's the same data, does it look like it's going down a lot faster? Yeah, and on the right-hand side, it's squished a little more, right? So it looks like it's not really going down very much. But it's the same data, and if you look at this data right here, how far is it from the top number to the bottom number? It's only 3 points. So 3 percentage points, they stretched it out to make it look more extreme. Or they condensed it to try to, show that it's really not that much. But that's important to see. These are deceptive practices you're going to see all the time. All the time. Okay, another one, I got a good story for you. You guys ready? Okay, so let's say, for instance, you're watching a TV show, a late night TV show that's supposed to be funny. Okay, in this TV show, it is sponsored by this drug company that makes this monkeypox vaccine. Okay, they make a shot for the monkeypox. Okay, there is no such thing, just so you know. Okay, so on this show that someone is texting about right now during my class, because heaven forbid they pay attention all the time, this shot is, so they sponsor. So what do you think the people at this late night comedy show is going to say about this shot that the sponsors of the show, the people that paid for the show, are giving them money? The people that actually paid for the show are the ones that make this shot. What do you think they're going to say? Are they going to say good stuff about it? No? All right, did you fall asleep? Okay, let's try this again. Okay, here's the situation. A late night show. On the late night show, they are sponsored by this group or drug company that makes a monkeypox vaccine. Okay? They're sponsored by them. So think about everything that's in that show. Do you think they're going to say bad things about the people that pay them? No. They don't say bad things about the people that pay them, right? Otherwise, they're not going to get paid. So that's one thing that you guys got to look for. Who is saying the information? Yes, that is another way to have descriptions or deceptions in these. So who's saying the data? Or is the data stretched out to make it look worse than it actually is? Or, yeah, this one right here, this one makes it look worse. All these things are important. Is there a title explains what is being displayed? Okay? Number lines up with tick marks on vertical axis to clearly indicate the scale. That's important. Okay? Vertical axis to clearly mark the scale. Are they varied to create more or less dramatic impression as shown by the actual data? Do too many designs and cosmetic effects draw attention from the or distort the data? Has the wrong impression been created about how the data is being changed because equally spaced time intervals are not used on horizontal axis? So that means you have to label the bottom with the bottom horizontal axis. Are bar sizes scaled proportionally in terms of the data represent? So the bars, do they look weird? Are they squished? Is one longer than the other? Oh, okay. Okay, and is there a source? Indicates where the data display came from. That's important. So that goes back to what I said. Who is paying for the data? So the guy that makes the monkeypox vaccine, if that's the person that's paying for that data, do you think it's going to be good? It's probably good for them, right? Do the data come from the entire population as sample? Was random sample used? Okay. Differences, entire population. Who is presenting the visual display, and do they have a special case to make for or against the trend shown by the graph? Okay, that's that late night host that's getting paid by the people that make the monkeypox vaccine. So they're going to say just good things. Here's an example, and I'm going to show you here. This is a vertical and cosmetic issue. If you look at the graph right here, they have cosmetic. They make these graphs, these bars, look like they're going straight up, right? Say yes. Okay, do I have a axis here indicating what is the increments? No. Okay. What about down here on the bottom? This says 1980 to 1990. How many years is that? That's 10 years. What about from 1990 to 2020? That's 30 years. So are they skewing this to make it look different? Yeah, it should be equal increments and it should be labeled correctly. That's important, and that's what it's talking about here. You got to actually look at things. Now, before we get too far, hold on. How much time do I have left? I got 10 minutes? Okay, good. So, I need a volunteer. Okay, you have been voluntold. You ready? You are going to do number 43 from the homework. Here is 43 on the homework.
43? You mean 34?
34, sorry. I'm dyslexic. Shut your pie hole. Here it is.
That's a bad graph.
Why is it a bad graph? How is this one deceptive?
Why is it showing dogs? Where does this, like, where are the points at? Is it by the tail, by the head? I don't know, that's weird. That needs more, like, details in it.
Okay.
It needs to be more labeled
More labeled where?
on the both sides.
On the y-axis here, right?
Yes.
On the y-axis, that one needs to be labeled. What about down here on the x-axis? Is that actual any increments or anything?
No.
No, there is no increments. There is no units. It just says excuses.
Well, I mean, it's kind of labeled on the top. It can speak to the bottom.
Yeah, it kind of is, but what else can you tell me about this? It was one of your first things that you said.
Dogs?
Yeah. Is it distracting?
Yeah.
It's very distracting, isn't it? So, is the comedic, is it because they have all these picture of dogs? Is this distracting from the data that you're trying to look at? Yeah. That's why this is deceptive. Yeah, go ahead.
There's too much information by trying to place it into one team.
Yeah, it's all these, it says it excuses. You know, that's not really a way to measure this. So you should have not understanding the assignment, okay? So the excuses by college students for not meeting assignment deadlines. Illness, computer problems, death in the family, family emergency, left assignment at home, and oversleeping. It doesn't really make sense. There's no increments. There is no uniformity. There is no reason, right? Does that make sense? Okay, so that's how it is deceptive. You can go down that list of the reasons that we went through and underline to find how it is deceptive and what makes it deceptive. Okay, so great answer. Thank you very much. All right, you guys. Hey, like, share, and subscribe. Hit that notification button and support my channel. Buy stuff from my merch store.